guys know. No weird stuff, no funny stuff. We're good. All right. This is recording. So let's talk about this practice quiz. Practice quiz starts off by saying, Great Britain has a great literary tradition that spans centuries. One might assume then that Britons read more than citizens of other countries. Some Canadians, however, feel that a higher percentage of Canadians than Britons read. A recent Gallup poll reported that 86% of 1,004 randomly sampled Canadians read at least one book in the past year, compared to 81% of randomly sampled Britons. Do these results confirm a higher reading rate in Canada? Test an appropriate hypothesis and state your conclusions. So there's a few ways you can approach this. Okay. And we're going to do it this way. So we're going to start, you know, usually, well, in the notes it said P1 and P2. You know, let me grab those notes real quick. Oh, right here. We did stuff like this right here, like the P1 and P2. Okay. While we're doing what's suggested is actually you make it a little bit more descriptive and you give some sort of key for your description. So instead of saying P1 and P2, we're going to say P1 is Britons, P2 is Canadians. We're going to go through the assumptions about it being random and it being at least, 10 successes, 10 failures with no more than 10% of the populations. Also, you have to consider, is your sample size big enough? Okay, so we're assuming that 1,000 Canadians and 1,000 Britons basically is not 10% of the population. You're going to have at least 10 successes, 10 failures. They said that it was sampled. It was Gallup. We trust Gallup. So yeah, all the assumptions are met. Now in this case, what you're going to see, kind of weird and fun, but a lot of times you'll see it written in alphabetical order of whatever you did for your setup. So that's why we did B and C, Britons and Canadians. So it's PB minus PC, PB minus BC. Remember, your null hypothesis is always equal to 0. Remember, I kind of was saying that the null hypothesis is always going to be equal to 0, whereas your alternative is going to be the same setup, but it's either going to be not equal to, it's going to be less than, or it's going to be greater than. Okay, so with it set up, this is our hypothesis that if you were to subtract them, they would be equal. The alternative is Britons minus Canadians is less than 0. So just be careful. However you set it up, you see how it says a higher reading rate in Canada? But I decided to put this in alphabetical order. If I put PC minus PB, then that would be greater than 0. But because I decided to put it in alphabetical order, PB minus PC, if it's switched, and if Canada is higher than Britain, okay, if this was a bigger number than this number, then if you were to subtract it from that number, right, it would be a negative number. It would be less than 0. So one more time. And the reason why I switched this to less than, even though the problem said higher reading rate, was because I switched up which one went first. And I chose to do that because of alphabetical order. Is that what you should do? There's no real rhyme or reason. There's no one way to do it. It's not like order of operations. You just got to be mindful of what you're doing. Okay, I could have put PC minus PB, but something in my mathematical brain says that's in the wrong order. And so what I did was I made an adjustment. I switched which order I subtracted them, but I switched the way the sign went here for the less than, okay, instead of greater than. All right, so let's identify what we have. We have the probability or the proportion of Britons, which was 81%. So I changed that to a decimal, okay, 0.81. I then did a quick calculation to find what the Q value would be. So the Q is always what makes us 100%. If 81% of the proportion is they read at least one book last year, then 19% would be the ones that didn't. Okay, if you want to confirm, 1 take away 0.81 is that, or you could do 100% minus 81%, gives you similar number, right? And then they gave me the sample size of Britons, which was 1,009, okay? Now, for the Canadians, it said there was 86% had responded that they read one book last year or the previous year. And so doing some quick calculations, 14% or 0.14 of the proportion would say they didn't read a book. And then the sample size for the Canadians was 1,004. So you notice the numbers are all kind of similar, right? Remember, we're trying to test if there's a difference. We're trying to say, did more Canadians read than Britons? Now, I know that these samples are obviously different, and it says here the Canadians had a higher percentage. You know, with stats, this sample is not necessarily, the sample is not necessarily like 86% of Canadians didn't necessarily read at least one book. It was only 86% of that sample. Okay, same with the Britons. It's not 81% of all Britons. It's just 81% out of 1,000 of that sample. But we're using that sample as a reflection of the total population. So we've got to calculate that little leeway and all that kind of stuff, right? And that's the same with the Britons and the same with them together. And so that's kind of where this standard deviation has to come in, because we have to be aware that just because it's 86% in this sample doesn't mean it'll be 86 in all samples. Just because that's 81% in that sample doesn't necessarily mean that's 81% of all samples. However, since they're both big sample sizes, we feel pretty confident that it's sort of close with only a little bit of wiggle room, right? So let's calculate that standard deviation and the mean for this problem, okay? So the standard deviation, we write it like capital S, capital D, parentheses, PB minus PC. You keep the same form as this. And starting with the Britons first, I did P times Q divided by N, P times Q divided by N, and then I square rooted it, okay? Now, with this one, as I was going through it, it said 0.81 times 0.19, and I divided that by 1,009. I got a tiny number. That's 0.000152527, whatever. And so when it says like something like -0.4, that means put 3 zeros in front of this. This is like a scientific notation for a calculator like this. And on the calculator you're using, depends on what it'll do. So if I was to cut this off here, it's going to diminish my answer. So I try to do the best I can to just keep this going. So a few things you can do with this is you can do stuff like parentheses. You could do even square root. Let's say parentheses, and then I'm going to do, I'm going to do a second set of parentheses and say 0.81 times 0.19 divided by 1,009. Close that first set of parentheses off. Add that to another set of parentheses, 0.86 times 0.14 divided by 1,004. And then close that off, close off the outside parentheses. This is the square root of all that business, and I get a fun number like that. So when you square root a small number, it actually gets larger. So that's why I went ahead and just did the whole thing without any rounding. And when I do that, I'll get a number like that. So I went ahead and cut it off at 4 decimal places. Okay, you can do 5, 6, or 7 here. The more you do, the more accurate your number is going to be. I would say the 10,000th place probably is okay for what we're doing. So I got for a standard deviation, right, of my difference is that. And then I found the average. The average says to subtract, right, PB minus PC. That was what we had took notes on Monday. And so that's how we calculate and get the -0.05. Now, the z-score, you're going to take your average minus the standard deviation you thought you were going to get, or sorry, minus what you're trying to do here. So it's this number, take away that number, and then divide that by your standard deviation. Okay, that was, put a little note here, it's your mu. Woo. Right. For your z-score, you're going to use your mu, take away 0, divided by your standard deviation of, 1 minus P2. So it's always going to be whatever you got for this score, take away 0, so it shouldn't change. Divide by your standard deviation, you get a z-score, and they're going to go to the z-table and take a look at that z-score. But what we're going to do, when we go to our z-table, okay, I found when I went to the z-table at negative 3.030, I got 0.0012. Okay. And so, since we got a low p-value, we're going to reject the null hypothesis, okay? So when it says test an appropriate hypothesis, that's going to be all this work here, all this goodness right there. Okay. State your conclusions. Now, there's more you can write, more you can do. I'm just going to keep it simple and just do this. But AP test people, if you're taking the AP test, which I don't think anyone is, there should be probably about 2 more sentences you should write, but we're going to cut it off there. All right. So when it says here a confidence interval, that is where we're going to take our average, right? And we're going to add, subtract that z star, which will always be 1.96 because we're always going to be doing 95%. And then we're going to times that by our standard deviation. So for the sake of time, let's go ahead and knock this out. Right, this is for our confidence interval. So I'm going to go ahead and say our mu was a negative 0.05 plus minus 1.96 times our standard deviation of 0.0165. This is going to give us a low and a high number of possible differences. So let's start by doing the -1. Okay, I'm going to take a negative 0.05, take away 1.96 being multiplied by 0.0165, and I get that lovely number. And this is my low number. Let's just cut it off at what's that, thousandths place? And then the same thing. I'm going to say negative 0.05 plus this time 1.96 times 0.0165. Yeah. And I get that lovely number, a negative 0.01. Let's round that up to 8. Okay. So what that basically means is oops. I'm going to put this into a better, easier to read context since the problem they gave us was in percentages. All right, so we got 1 minute. Close it out. So I got a confidence interval. Now I have to interpret it. So what this tells me, that negative 8% to negative almost 2%, that is the estimated, we are 95% confident that the true difference in the reading proportion is Canadians have a higher rate between 1.8% to 8.2%. Okay, this confirms that Canadians read more than Britons. Okay, I'll upload this answer to you shortly. I'll put this video up shortly if you're having trouble. Okay, it is time to kind of go, but that's what we're doing for this chapter. Okay, it's a little bit of mathematical calculations. You should have a calculator, whether it's a handheld one or whether it's one on a computer, your phones, whatever. Okay, but you should be able to calculate these numbers. Okay, it is 7:54. It's already after class, so I'm going to go ahead and cut this recording off.